All right, so today we're going to be talking about linear and angular speed, and we're going to be using, so we can use arc length and stuff in order to analyze our circular motion. So what we're going to be doing is talking about revolutions, and then we're going to change those to angular speed and to linear speed. So if I have 125 revolutions per minute, so 125 revolutions per minute here, and I know that it takes me 2 pi radians to go around 1 revolution. All right, so 2 pi radians is equivalent to 1 revolution here, and this is supposed to be like a little radian right in the center. So like we're talking about a radian motion there. So this whole thing would be 2 pi's, right, that angle measurement. So that's why I'm going to do 125 revolutions per minute times 2 pi radians per 1 revolution. So my revolutions are going to cancel for me, and then I'm going to end up with 250 pi radians per minute. So that's what your angular speed would be. So then you know it's radians per minute, so you know it's an angular speed. Now to find linear speed here, so what I need to do is linear would be like circumference here. So a circumference of a circle is pi d. So pi d is 1 revolution around the circle here. So I'm going to take the 125 revolutions per minute that gave me, and then I'm going to multiply that by my pi diameter of 1 revolution. So if it's 14 inches here, then I'm going to use 28, the diameter, sorry, 28 pi inches per 1 revolution, right? So the circumference of this circle would be 28 pi because like your circumference equation is pi d. So again, my revolutions cancel for me. So now I'll be doing 28 times 125. 28 times 125. So I get 3,500 pi. So 3,500 pi inches per minute. So that is your linear speed. So linear, so we're in inches. So the idea behind these, what you're going to be doing is, so when you're doing linear speed, we're going to be using circumference. And when I'm doing angular speed, I'm just going to use the conversion of radians per minute. So next one, a CD with diameter of 120 millimeter rotates a rate of 45 revolutions per minute. We want to find angular speed first. So angular speed again, 45 revolutions per minute. Remember, 1 time around a circle is 2 pi radians, so that's why we use that conversion, 2 pi radians per 1 revolution. The revolutions will cancel for me, and I'm going to end up with 90 pi radians per minute. So that's your angular speed, 90 pi radians per minute. So linear speed again, circumference times your diameter. Circumference equals your pi times your diameter. So we're going to do the circumference times your revolution to get linear. So I'm going to do 45 revolutions per minute times, so it would be, the circumference is 120 pi millimeters per revolution. So we do 45 times 120, and I get 54, so I'm going to get 5,400 pi millimeters per minute, because the revolutions cancel for you again. All right, this one, a 16-inch diameter tire on a car is making 500 revolutions per minute. Find the linear speed of the tire in miles per hour. So up here is the linear speed, and this is in millimeters per minute. So we're going to do the exact same step here, but then I'm just going to convert these 2 units so that it ends up being miles per hour. So I'm going to have 500 revolutions per minute. And then this is linear, to say linear, yeah, linear. So I'm going to take my 16-inch diameter, so 16 pi, that is inches per 1 revolution. And if we did this right here, this would end up giving me inches per minute. So I just need to change inches per minute into miles per hour. So then I'm going to say I need my inches to cancel and put inches on the bottom. So there's 12 inches per 1 foot. You guys see that I'm just setting it up so that they cancel. And then I need feet in a mile. So there are 5,280 feet per 1 mile. So this will cancel out my feet. So now I changed feet, now I need to change minutes to hours. So then I'm going to multiply. So I need minutes to cancel, so I'm going to put it on top. So 60 minutes per 1 hour. And then we're just going to go ahead and multiply. So my minutes here cancel. I'm left with an hour on bottom. Revolutions cancel. My inches cancel. My feet cancel. So on top, I'm left with miles. And on bottom, I'm left with hours. That means I know I did it right. So I'm going to do 500 times 16 times 60 on top. So we get that number. So we have 480,000, and that is in miles, over 12 times 5,280. And this is hours. So I'm going to go ahead and divide those. So I get about 7.57 miles per hour. Let's say 7.6. Oh, times. Oh, I forgot to times it by pi. Times pi. Ding dong. Sorry. This is pi miles per hour. So multiply in your pi, and we should get 230.8 miles per hour. So don't leave since it's already a decimal, I would just go ahead and multiply in that pi right there. All right. A circular saw blade with a diameter of 9 inches rotates that many revolutions per minute. Find the angular speed of the blade in radians per second. So I need radians per second. All right, so I have, let's see, a diameter of 9 inches. So I have 2,800 revolutions per minute. And then I can change that. So radians per second. When we were making these before, remember I had radians per minute as my unit. So all I need to do is to do the exact same process, but instead of changing it to minutes, I'm going to have to change it to seconds. So this is revolutions. So I know that I have 2 pi radians per 1 revolution. So my radians are on top now. So these cancel. So now I need to change minutes to seconds. So I know, let's see, 1 minute is equal to 60 seconds. All right, so let's multiply across on top. We get 2 times 2. So we get 56 pi. You see minutes canceled. So I'm left with the radians on top. Divided by 60 seconds. So let's go ahead and divide that. So multiply that by pi. Then divide by 60. So I get 293.2 radians per second. So it's the exact same thing we were doing on front. We're just changing, instead of it saying per minute on bottom, we're now saying per seconds. A windmill has a blade that's 14 feet long. If the windmill is rotating at 5 revolutions per second, find the linear speed in miles per hour. All right, so I have 5 revolutions per second. So I need to change this to linear. So that's your circumference, is what linear means. Remember, it's pi d. So I'm going to multiply this by 14 pi. Hold on. The blades are 14 feet long. I wonder if it's, hold on, let me think. If it's a blade like this, then maybe I need to double it to 28, is what I'm thinking here. So make this 28. I was thinking at first that the blade would be like a straight across, but then I started thinking about how windmills will look, and it's actually 14 would be your radius. So 28 pi feet per 1 revolution. So now my revolutions, so if I multiplied that across right there, that would leave me with feet per second, and I need it to be in what, miles per hour. So let's change miles now. So there's 5,280 feet in 1 mile. So now my feet will cancel for me, and then I need hours. So I need to change seconds to hours. So I have 60 seconds equals 1 minute times 60 minutes equals 1 hour. So let's see, the minutes will cancel for me, the seconds will cancel. So I'm going to be left with 5 times 28 times 60 times 60. So that times pi, and that's in miles. And then the only thing on the bottom is the 5,280. So times pi divided by, so I have 299.9 miles per hour when we do that. All right. So now it says we could use linear speed could also be used to find angular speed. So if we use angular speed as W and linear speed is the letter V, then it is R times W. to find it. So our first one, we have a ceiling fan with 25-inch blades, rotates at 40 RPMs. Find the linear speed. So that is radians per minute, I'm assuming. Find the linear speed of it. So let's change. So our angular speed would be, so if we have 40, that's revolutions per minute. So revolutions per 1 minute. So I'm going to multiply this by my angular to get my angular speed. That's 2 pi radians per 1 revolution. That's going to give our angular speed. So that will be 80 pi radians per 1 minute. So that is going to be the angular speed. And then we need to multiply that. Let's see, we have 25 inches. So we can multiply that by 25 inches. So we're going to multiply that by the radius and then change that from inches to what we need. So that'll be 25 inches, and we have 1 foot is 12 inches. And then I need to change my minutes to seconds. So 1 minute is equal to 60 seconds. So minutes cancel for me. My inches will cancel for me. So then I'll be left with feet per second. So I'm going to end up with about 8.7 radian feet per second down here. So let's see. He has a wheel whose diameter is 28 inches. If the wheel rotates at 130 revolutions per minute, find the linear speed in miles per hour. So we're going to do 130 times your 2 pi, because this is revolutions per minute, and this is radians per revolution. So we get 260 per minute. So just converting all of this, we're going to do times 14 inches times 60 minutes per hour times 1 foot per 12 inches times 1 mile per 500,000, 280 feet. So start canceling everything out. We're going to get 10.8 miles per hour.